Let's build an artificial neural network in Scikit-Learn. We're going to use the breast cancer dataset for this example. As you know, breast cancer dataset is a binary classification problem, and it had 30 features and 569 samples. Happy coding. Let's start with importing the libraries that we need. We need to import the Mlp classifier from neural network module. So M, L, P, and C are capital. Also, to work with the data, we need to import the data. We're going to work with the breast cancer data. Also, we're going to standardize our data or normalize our data using the min-max scaler. So we're going to import the min-max scaler. It's in the pre-processing module. And here also we're going to import the train test split for splitting our data. I'm going to import it as a split. Also, we're going to import the accuracy score. Next, we are going to split our data, load our data, and then split it to X and Y. Right. Now we are going to split our data into training and test. I'm going to use the test size of 20%. And random state 0. And here we're going to scale our data. So I'm going to define a scaler as min-max scaler. And I'm going to scale our data, the training data, and test data only the feature variable. And also the test data. All right, our data is normalized now. Now we are ready to build our model. So we want to build a 2-layer MLP with 100 and 100 units of neurons. So let's start here. I'm gonna build my algorithm. I'm gonna call it MyANN, and that's going to be a copy of Mlp classifier. The activation function by default is reload. So here we're going to use the tanh. The hidden layer size is going to be 10 by 10, layer 1 and layer 2. For alpha, we're going to initialize it to 5. We can change these values later on and play around to see which one would work better. Also, for random state, I'm going to use random state 0 so that all of us would get the same output. And for solver, I'm going to use LBFGS. Okay, so we can actually, all right, let's actually feed our algorithm or train our algorithm. Right, our algorithm is ready for make a prediction. All right, let's now go ahead and make a prediction on test data and training data. So we're going to use the scale data, and we're going to do the same for the training data. All right, let's now print out the accuracy scores. We need to give the first original or the actual value first, and then the prediction. And we're going to do the same for the training data. Right, so the accuracy on the test data is about 96%, and the accuracy on the test data is 96%, and training data is 98%. Let's now take a look at the advantages and disadvantages of artificial neural networks, starting with the advantages. Artificial neural networks, which are also called neural networks, are the basis for state-of-the-art machine learning models, including deep learning, and can be formed into advanced models that could effectively capture complex features given enough data and computation resources. That is why the neural networks and deep learning are among the most popular algorithms and models for complex problems that we have in real life, such as image recognition or sound recognition or developing driverless cars. Let's now take a look at the disadvantages of neural networks. Large complex models, those neural networks with a lot of hidden layers and hidden units, would require significant training time, data and customization, as well as memory. They would require careful pre-processing of data. And they are not a good choice when features are of very different types. Mlp Classifiers Key Parameters. The first one is the hidden layer sizes. This parameter sets the number of hidden layers and number of hidden units per layer. The default is 100 units per layer. We set the value of this parameter using a list of the number of units per layer, and we separate the numbers by a comma. So for example, this would set 3 layers. The first layer has 100 units, the second layer has 150 units, and the third layer has 200 units. A total of 3 layers. Alpha controls the weight on the regularization penalty. The default value is 0.0001. Activation controls the nonlinear function that is used for the activation function, including the ReLU, which is the default function, logistic and hyperbolic tangent, and more.